A very good evening, everyone. Am I audible to all? And is my screen visible? Okay. So let's just give me a minute. Yes. So anyone having any doubts in any of the questions so far? Yes, no, anything? Okay. Any other person who has any doubts so far? You can clear it out. Okay. If you guys have no doubts, I'll just discuss few questions quickly. So our next question here is, this question is named as coin change problem. Okay, so you have been given an array of coin denominations. Basically, let's suppose I'm giving you the coins array, which is having like you have 1 rupee coin, you have 3 rupee coin, 7 rupee coin, and 10 rupee coins. Okay, and you have been given an integer, which is you can say the targeted money. That is, let's suppose here I'm giving you as 15. Clear. Now you have to find out the minimum coins required to make the change. Like, let's suppose you have the money as 15 and you want to get the change. So you need to find out like in what way you will get minimum coins and as well as the change equal to your given money. Is my question clear? Which I am explaining here. So if I tell you guys the ways, so you can take like number of coins which is there in an array is infinite. Okay, so you can take 15 1 1 1 1 rupee coins and you will get the change equals to 15. You can take 3 3 rupee coin for 5 times and you will get your change equals to 15. And similarly, there will be multiple way. Okay, correct. So in similar way, you may have many ways to get the change, which is whose value is equals to 15. You need to find the way in which you have number of coins, like you have minimum number of coins and you have the change of your money. That is 15 here. Clear? Okay. Guys, I only see one person responding here. Okay. So far, I have seen like this particular class has been good because like so many people are attending till the end. So if you guys are there till DP, you guys can also respond in the chat box that whether you're getting something or not. Okay, fine. So any questions here or will you be able to do it? I can try. Okay. Will you like to give it a try like now itself or will you like to take it as an homework and try later? Okay, take it as an homework. Next is a rod cutting problem. Just a This is known as rod cutting problem. Okay, so in this specific problem, you have been given the length of the rod n. Let's suppose I am taking it as an 8. So you need to find out that in what way you cut the rod so that you can get maximum profit out of it. And for that, you have been given the length you cut and the price you get for that length. This is given to you. That is, if the length is 1, the price you will get is 1. If the length is 2, the price you will get is 5. If the length is 3, you will get the price as 8. Similarly, 4, the price you are going to get as 9. 5 is 10. Next, if the length is 6, then you'll get the profit as 17. If the length is 7, the profit you'll get again as 17. And if the length you are cutting is 8, it is 20. So you have been given the length equals to 8. You have to cut the rod in such a way so that you can earn maximum profit out of it. Okay, clear or not? So there can be multiple ways you can cut the rod. But okay, can you tell me the answer for this specific problem? What will be the maximum profit you can earn? Can you guys tell me what will be the maximum profit you guys are gonna earn after like cutting this rod? Correct. And the max profit here is 22. I will give you one more example for this. Let's suppose I'm giving you another array. So here, length and price. Almost the same. I have just cut. Yeah, I have just changed the value of 1, like the length of 1 price I have changed. That is 3 now. Other than that, the entire array is same. Can you tell me the max profit earned now? No, it's not the max profit. Think of something better. 24, correct. Take like partition your rod into length of 1 parts and you will get your max profit as 3 multiplied by 8, which is 24. Correct. Anyone having any doubts so far? Okay. So will you give it a try? These are all 1D DP problem, which includes the optimal substructure. So try to give it a shot on your own. And if you are not able to do it, then we will obviously discuss this. Yeah, Vishnu, it's okay. I have discussed two of the problems. So maybe you can discuss it like you can discuss it at the end of the class with me or with any of the classmate. Right now, I'm moving on to a new problem. So you can continue from there. Exactly. That's why, and these are I'm all giving to you as an homework because these things require your thought process first and then only like it can be discussed in the class. Otherwise, it's like of no use. Okay. Next question. It is also an important question. Its name is max non-adjacent sum. So in this particular question, what is given? You have been given an array of n numbers. The numbers are 6, 10, 12, 7, 9, and 14. You need to find out that what will be the maximum sum of the non-adjacent elements that you can get. That is, you cannot add the elements which are adjacent to each other. Okay, and considering that condition, you need to tell me what is the maximum non-adjacent sum for this specific array. Getting the question? Adjacent means side by side, correct. Vishnu, do a little more search and find out. It's not the correct answer. We can add 6, 12, 9. 9 and 14 are adjacent. Kishan, we can't take that. 9 and 14. Correct. So the answer here is 6 plus 12 plus 14, which is going to give you the answer as 32. This is the answer for this specific array. Clear? Clear, everyone? Okay. Any questions you want to ask in this specific problem statement? Okay. No one in the class is having any questions? Okay. So again, would you like to give it a
I was thinking,
yeah?
like how will we apply DP into this, like overlapping problem, because it's just
Say.
uh, it, it, how it is a DP problem. I mean, the numbers are like going one way. How can we reuse this from the
Okay.
perspective of?
Okay. Yesterday we understood the Kadane's algorithm, remember?
Yeah.
Yeah. Was it actually looking like a DP problem?
No.
No.
But yeah, it was there.
Basically, the thing here is like why we consider these problems into the DP approaches is like you consider 6. Okay. Now I'm just telling you one way. You considered 6, then you considered 12, let's suppose, and you considered 9. Can you take further numbers? Can you take
No.
numbers further? No. Now let's suppose I'll say I got this sum, but I am not sure if it is maximum or not. So what will I do? I will backtrack. Backtrack in the sense, instead of taking 9, 7 I can't take, 9 I'm like skipping now. So what is left? 14, right?
Yeah.
Yeah. So I
Yeah.
go to 14. Other than that, now what will I do? I am like done with 14 also. So now I'll think that okay, if I'm at 14, I should not try shifting this 12. So now what will I do? I'll shift this 12. I'll take 7 now. After taking 7, I'll take 14. So what will happen now? I'll take the sum and I'll see if it is greater than the maximum or not. Getting me?
Yeah.
Yeah. After this, when I have taken 7, I can't take further like numbers ahead of 14, right? So again, I have to backtrack and I have to take 9 as a number. If I take 9, then only 6 and 9 I can take, right? Because no other number I can take now.
Yeah.
Yes.
12 we can take in the middle.
12 we can take, but that particular approach we have already, like that specific
Okay, taken
step we
care.
have already considered, right?
Yeah, yeah, yeah.
Yeah. Now again, backtrack, we'll take 14. After this, nothing is left. So what we will do, we will backtrack completely. We'll start taking from 10. I took 10, I took 7, I took 40. And similar way, we are considering all the approaches that can be taken.
Yeah, yeah.
Are you getting it? And that is what increases our time complexity. So in these kind of questions where like we need to repeat our sets or like taking sets, in that questions we try to implement deep. Okay, like it's not an
Okay.
exactly overlapping subproblem or optimal substructure. It does not fall into that category, but still DP can be implemented into it. Clear?
Okay.
Okay. Okay, so I guess I have given you how many questions today? 3 questions, right? From the 1D DP? Yes, no. Do you guys want more? Okay. For today, you just try these 3 questions as an homework. And now I will like to discuss 2 DTP question today. So for today, you guys have these many homeworks. Try to finish it up today. I just asked, do you want more questions, or is it enough for today for your homework? So our next question is longest increasing subsequence. In this, you have been given an array of n numbers. The numbers are 5, 8, 3, 10, 15, 6, 9, 1, 10, 12, 2, 18, 7, and 11. So the question is, you need to find the longest increasing subsequence, that is that whatever subsequence you are getting, the length should be longest, and you can just a minute. Yeah, and it is in the ascending order. Like that is, it is in a sorted order. If I take the subsequence as 5, let's suppose I took 5, I can take 8 because it is following the ascending order. Can I take 3 in my subsequence? No. I'll take 10. I'll take 15. Can I take 6?
No.
9, 1, 10, 12, 2, 18 I can take.
Yeah.
18. Other than that, I can't take any number. So the length here I got is 1, 2, 3, 4, 5. So can you guys tell me what is the longest increasing subsequence you can get out of this specific array? That is the question. Clear?
Yeah.
Okay. So think of it a little bit. And can you tell me what will be the longest increasing subsequence in this specific question? Yes, guys, can you tell me the max length?
6.
I have, yeah, 6 is the correct answer. And I have not picked the longest one so far.
Yeah, it'll be like 3, 6, 9, 10.
Yeah, either you can pick up 5, just a minute, 8, 9, 10, 12, and 18. This can be the one possibility. Other possibility can be 3, 6, 9,
10.
10, 12, and 18. So both of these sequences has the longest length, which is 6. So you need to return 6. Clear? Brute force, I guess you guys know. Yes, no? Yeah, can I assume you know the brute force for this?
Like brute force would be just going from left to the right, checking what is the uh, increasing order of the numbers.
Mm-hmm. Just
And creating subarrays. No. Yeah, creating subsequences from the left to the right.
I'm not getting you. Vishnu, can you repeat again?
Yeah, so creating subsequence starting from the left to the right,
Mm-hmm.
um, and as soon as there is, we'll just keep on adding the count, and then going from left towards the right, then incrementing the pointer from 0 to 1 to 2, like that.
No, subsequences, I guess you guys know, right? Like how to find the subsequences? Yes, no?
Yeah, we did that long ago.
Long ago we did, but don't you remember that? For 1, 2, 3, we have 8 combinations. Correct. That's correct. Like if you have 3 numbers, 1, 2, 3, you can pick just one, you can pick 1 and 2, you can pick 1, 2, and 3, then you can pick 2 and 3, you can pick 1 and 3, and what else? You can pick 2, you can pick 3, you can have null. So these are all your subsets or subsequences. Are you getting it?
Yeah.
Yep. So basically, it takes 2 to the power n times to find all the subsequences. Okay. Once you have found the subsequences, you will find what is the length of it, which will take another n time, and that's it. So this is via, that is, you are doing all, like generating all the subsequences and then calculating the length at the end. Next is you can calculate the length on the go or on the flow. So you can skip this n part and you will have the time complexity as 2 to the power n plus comma 1. That is the space complexity. Are you guys getting it? I'm not explaining here the entire approaches. I'm just giving you a very, very brief of this particular question. Are you guys able to follow?
Ma'am, 2 to the power n comma 1. 1, what does it mean?
Space complexity.
Space complexity. Okay.
Yep. Clear, everyone? Yes, no, anything?
Ma'am, how did
Okay.
we reduce to 2 to the power n? That is the number of sequence
Yeah,
time.
right. That is the number of subsequences generated, time taken to generate all the subsequences.
Yeah, and to compare, that will be n times.
To compare, basically you have, see, you will be having a subsequences, but you need to see now that what the subsequence which is generated is in increasing order or not. So that will take n time of yours, right?
Yeah, yeah, yeah. So brute force is I'm fine. 2 to the power n into n.
Hmm.
That's fine. But the lower one I'm not clear. 2 to the power
It's
n.
basically like that. See, what you are doing in the first one, you are getting your subsequence and then you are checking if it is increasing or decreasing, right?
Yeah.
In the second one, it is like like one by one you are taking the numbers, you are keeping a track that whether the subsequence you are taking is in the like ascending order or not. If it is not in the ascending order, you are just skipping that sequence. So
Okay.
if you are calculating it on the go, you are skipping that n part.
Oh, okay. Got it.
Clear?
Yeah.
Okay, perfect. So this is the introduction to this particular problem, and I hope you got the introduction part. Will you guys like to give it a try for the like the DP solution for this and how the DP can be implemented in this? I know like you guys can understand that DP can be implemented in this, but will you try to give it a shot? Yes, no. Okay. So I'm giving you today's time. You guys can like go and see this particular problem and the remaining problems I have given, and then we will discuss those problems in the class. Will it be fine? Okay, and coming on to the next problem, which I'm going to discuss in the class, is a knapsack problem. Has anyone heard of that ever? Okay, in college, right. So knapsack problem is a very interesting problem. We'll discuss this in the class after all these problems has been discussed. And I guess then one or two problems will be left, and then I guess our DP will be over. Clear, everyone? Okay. So I'll close the call here only for today, and we'll see you guys tomorrow with the answers of these all questions, or either we will discuss all these questions. Okay.
Ma'am, knapsack, how do you spell it?
Knapsack.
Can you?
Knapsack.
That we'll discuss tomorrow.
Not tomorrow exactly, but once we are done with all these problems which I have discussed today.
Okay. Okay.
Okay. Okay then. So thank you for attending today's session. I'll see you guys tomorrow. Bye bye.